we need to determine the locus of the point of intersection of the lines x times cosine alpha plus y sine alpha equals to a, and x cosine alpha and x sine alpha minus y cosine alpha equals to b, where alpha is a variable. Let us begin. So here we will consider two lines that are intersecting with each other. So here we have the equation, let's say we'll consider one of the equation as x cosine alpha plus y sine alpha equals to a. That's the equation of one of the line. Then we have the other line which has the equation given by x sine alpha minus y cosine alpha equals to b. Now clearly we observe here that both the two lines are intersecting at a common point, and we're going to name it point P with the coordinates h, k. So our goal will be to obtain the locus of that particular point P. Now, since we can say that since the point P lies on the line, let's just call it equation number 1, and the second line is equation number 2. Now we can clearly observe here the point P lies on the line given by equation number 1. So that means its coordinates are going to satisfy the equation of the line. So that would mean that we can replace the value of x with h. So we have h times cosine alpha plus y. The y will be replaced with k. We have k times sine alpha. This will be equals to a. We're going to label this as equation number, let's consider it to be equation number 3, since I've already chosen 1 and 2. Next, we can also use the same logic here. P also lies on the second line, equation number 2. So that means it is also going to satisfy the equation of the line as given in equation number 2. So equation 2 is going to become h times sine alpha minus k times cosine alpha. So this will be equals to b. Let's name it as equation number 4. Now what we'll do, since alpha is a variable that's already specified in the problem, we'll use equation 3 and 4 to eliminate the alpha value. All we have to do is we're going to square equation number 3 and add it to square of equation number 4. So let's do that. So on the left hand side, we're going to have h times cosine alpha plus k times sine alpha. We're going to square it and then add it to h times sine alpha minus k times cosine alpha whole squared, and that will be equals to a squared plus b squared. Now let's expand. We get h squared times cosine squared alpha plus k squared times sine squared alpha plus 2 times h times k times cosine alpha times sine alpha. Coming to the expansion of the next term, h sine alpha minus k cosine alpha squared, we're going to get h squared sine squared alpha plus k squared cosine squared alpha minus 2 times hk times sine alpha times cosine alpha. So this will be equals to a squared plus b squared. Now immediately we can observe, we can cancel out the term 2hk cosine alpha sine alpha and negative 2hk sine alpha cosine alpha. Right. Now we're going to combine the terms containing h squared. So if we take h squared as the common factor, this will get multiplied to cosine squared alpha plus sine squared alpha. Then we can combine the terms containing k squared. We have k squared times sine squared alpha added to cosine squared alpha. And on the right hand side, we have a squared plus b squared. However, it's a standard identity. We know that sine squared alpha plus cosine squared alpha. So this is a standard identity with a value equals to 1. So now what we are left with? We are now left with h squared times 1 added to k squared times 1 equals to a squared plus b squared. So that means we have h squared plus k squared equals to a squared plus b squared. So almost done. All we have to do is finally replace the value of h with x and the value of k with y, and this is going to give us the locus of that particular point, x squared plus y squared equals to a squared plus b squared. This is going to be the locus of the point of intersection of the two lines, which is given by equation 1 and equation